Well, hello everybody, and welcome to our fifth session of the CIVICA Data Science Seminar Series, hosted by the LSE Data Science Institute. I'll just start by saying a few words about CIVICA, which is a network of Europe's leading social science universities. So that includes the Hertie School, their data science lab, the CEU, Central European University, Department of Network and Data Science, the Bocconi Institute for Data Science and Analytics, Sciences Po Media Lab, and the European University Institute, as well as my own institution, the London School of Economics. Welcome to our seminar series, which is about the sort of social, political, and economic aspects of data science and real-world applications. So today, speaking to us, we have Dr. Melissa Sands from the University of California, Merced. To introduce Melissa, she's an assistant professor of political science at UC Merced at the moment. She has a PhD from Harvard University and an MPA from Columbia. And she's a social scientist who studies the effect of context on our political and civic behavior, how the things around us influence the way that we think and the kind of decisions that we make, how we sort of interact politically and in civic life. So I'm super excited to hear more about Melissa's research. Something exciting to update you all on is that she will be joining the London School of Economics in September this year. So we're excited about having her as a colleague in the near future as well. So with that, Melissa, why don't you tell us about your work on using public video cameras to detect racial distancing on city streets?
Hi, great. Thank you so much. I'm thrilled to be here and looking forward to presenting this work with you, which is a joint work with Bryce Dietrich at the University of Iowa. I'm just going to share my slides. All right. Okay, so here is Raphael Warnock, who this past January was elected as the first African-American to represent the state of Georgia in the United States Senate. He ran in a highly consequential race that determined which political party would take hold of that chamber and thus of the legislature. This was arguably one of the most important political contests in recent memory in the US, and one that was highly racially charged. So this is a shot from the filming of an ad featuring Alvin the Beagle, who is not actually Warnock's dog, and placed Warnock in a sunny, idealized suburban setting. So note the picket fence, the neat single-family homes. It was intentionally crafted for a very particular purpose, and that is to put white voters at ease. So in this case, Warnock was, at least in part, responding to inflammatory messaging from his opponent, Kelly Loeffler, who painted him as a fiery radical with ties to far-left Black activists, something, by the way, that Barack Obama's opponents tried to do as well. But it's reflective of something that Black people in traditionally white spaces feel the need to do every day: appear non-threatening, neutralize racial stereotypes, and placate white people who might feel threatened by their very presence in a public space. So why do Black people feel the need to do this? Most obviously, to avoid being racially profiled and possibly brutalized by the police. But also to avert more micro forms of racism to which they are constantly subjected, subtle indignities and so-called microaggressions. So here's a screenshot from a comedy sketch designed to serve as a PSA about how Black men are often treated by white strangers in places like elevators. So even though survey research suggests that most people explicitly reject racist messages, their behavior can belie persistent racial biases. Now, this behavior need not be obviously discriminatory. In fact, racial bias can be more apparent in subtle, nonverbal, and spontaneous behaviors like clutching one's purse than in more explicit behaviors. In the study I'm going to present today, we document a nonverbal manifestation of prejudice, racial avoidance in everyday pedestrian reactions. So why study racial avoidance? Links between nonverbal measures of prejudice and more explicit behavioral indicators of racism are well established in the literature. Physical avoidance in particular has been shown to track racial bias in laboratory studies. So for example, researchers have used immersive virtual environments to demonstrate that implicit prejudice against an ethnic outgroup, measured by an implicit attitude test or an IAT, predicts avoidance behavior, and that racial avoidance, as measured by interpersonal distance and head orientation in a virtual encounter, predicts aggressiveness and hostility towards Black males in a virtual gunfight. So we're interested in one of the most common, most pedestrian forms of in-person interaction, passing someone by on the street. We ask whether pedestrians avoid Black individuals on city sidewalks, and we operationalize avoidance by measuring the berth that pedestrians give to Black individuals compared to white individuals. So one way to answer this question is to simply look, right? We might go to street corners and watch how people behave, and some scholars have done exactly this, but this approach has some problems. So first is a confounding or endogeneity problem, right? Who uses a sidewalk in turn affects how and whether others use that space. And to help deal with this, we conduct a randomized experiment in which we assign confederates to stand on sidewalks. Another approach we might take is simply to ask people how they feel when they encounter someone from a different race group on the street. Or we might bring them into a lab and measure their behavior there. But then we face the challenge of social desirability bias. So since race can be a sensitive topic, simply asking people to tell us how they behave towards outgroup members might lead us astray. Popular strategies for getting around this problem by using measurement tools designed to capture implicit attitudes can yield results that are difficult to interpret or tricky to translate to actual behaviors. So our solution is to measure a real-world behavior. A related issue is experimenter demand effects. So we worry that participants will behave differently if they know they're being observed. Our solution is to use an entirely unobtrusive measure of real-world behavior. To do this, we use New York City traffic cameras. So New York City, like London and I'm assuming that other major cities throughout Europe have this too, is dotted with hundreds of public cameras. So in this setting, cameras are operated by the New York City Department of Transportation. As these are traffic cameras, they're not designed to monitor pedestrian behavior, but rather vehicular behavior. However, many of them capture sidewalks, particularly in the denser parts of the city, like in the island of Manhattan. So here's an example from a camera in Harlem, which is in sort of upper Manhattan, which captures the road, but also many pedestrians. So some things to note about New York City before I proceed. So we think that detecting racial avoidance in New York City is what we'd call a hard test. This is a place where we think explicit expressions of racism are less common than in many other places. The pedestrians who appear in our study are likely to be wealthier, better educated, and more politically left-leaning than the average American. These traits may, on the whole, make study participants perhaps less prone to obvious racial avoidance. Moreover, these are densely populated, highly stimulating settings. There are a lot of distractions to draw pedestrians' attention away from other pedestrians on the sidewalk. Okay, so let me give you a sense of our research design. Our sample is comprised of pedestrians who happen to be walking on one of the two stretches of street captured by our selected cameras. So as a first step, we identified cameras that show a large swath of unobstructed sidewalk and have relatively high image quality. Ultimately, we chose two Manhattan intersections that we felt represented different types of neighborhoods in New York City. One on the Upper East Side is more residential. Its residents tend to be older, whiter, and wealthier than New Yorkers on the whole. The other, Midtown, is much more commercial. It's still quite wealthy, but its residents tend to be more mixed. However, because this is a business district, pedestrians on this sidewalk come from all over the city. Midtown's actually known for its tourists, but the particular intersection we choose is not an especially touristy one. And we conduct the experiment over 2 days, 1 day in each location. Our experiment has 3 conditions. In one condition, we have phenotypically Black Confederates stand at a predetermined location on the sidewalk, which I'm going to show you in a moment. In another, we have phenotypically White Confederates doing the same thing. Finally, we have a pure control or no Confederate condition in which we use to validate our manipulations. Okay, so how do we randomize pedestrians into these experimental conditions when obviously we can't control when and where people walk? So we block randomized, meaning that we divided each day into 5 45-minute periods, then implemented the 3 conditions for 15 minutes each during each 45-minute period in randomly determined order. What this does is hold constant natural fluctuations in pedestrian traffic throughout the day, such as lunchtime and commuting hours. So here's a closer look at our Confederates, all of whom were undergraduate students at New York University and Columbia University. So from a research standpoint, the goal was to recruit Confederates who looked as similar as possible across pairs, and we instructed them to dress similarly across pairs. We intentionally recruited young men because young Black men are most likely to be stereotyped as threatening. In the future, we'd like to replicate the study and vary other attributes of our Confederates like gender, age, and ethnicity. So we pre-registered several hypotheses, and I'm going to focus in particular on 2 of them today. So first, we hypothesized that, on average, pedestrians will give a wider berth to phenotypically Black males than they do to phenotypically white males. And second, that this pattern will be more pronounced among non-Black pedestrians as compared to Black pedestrians. So more about how we test these in a few moments. Here's an image from our Upper East Side camera to give you a preview of our experimental setup. So this is the more residential setting in the Upper East Side. Our Confederates stand in a designated spot. So we had the inner Confederate stand on a seam or a line in the sidewalk to keep their position consistent across conditions. And they were instructed to have a conversation about a neutral topic unrelated to politics or race, such as the classes that they're taking, assuming those classes are not political science classes. Pedestrians would walk by, typically by moving up the sidewalk or down the sidewalk past the Confederates. Very occasionally, we see pedestrians crossing the width of the sidewalk, for example, to make a delivery to the building. And in the paper, we show that our results are not affected by their inclusion or exclusion. Now, using street cameras has its advantages, but it implies a measurement problem. Because we're interested in the distance between Confederates and pedestrians, we need to deal with distortions of perspective that arise due to camera angle. So what do I mean by this? Ideally, we would like a bird's eye view of our experiment. This image from Google Earth is the scene that we were just looking at, but from above. So you can see the green awning there that appeared in the previous image. So if we could do this, if we could look from a bird's eye view, measurement would be easy because we could just measure the exact distance from pedestrians to Confederates. So here are their approximate locations on the image. This C represents the approximate location of the camera. So there are distortions in any projection of a 3-dimensional space into a 2-dimensional image. But the problem becomes much more complicated when the camera is at an angle, particularly an unknown angle. If we knew the focal length of the camera and the height of the people, we could actually back out the distance, but we don't have that information. We don't know the focal length of the cameras. And as I said, the C here represents the approximate location of the camera and its field of view. This is particularly tricky in our context, or really anywhere that cameras have a relatively slow refresh rate rather than live streaming video, which is true of most public cameras. However, there's been a recent proliferation in better quality video, which I'm going to come back to at the end of the talk when I give you a little preview of another related project that I'm working on. Okay, so how do we deal with this? We pre-registered a measurement strategy intended to help address this issue. We picked what we call a baseline object that lined up with our Confederates on the same plane. This is just a fixed point directly adjacent to the Confederates, as if we'd drawn a line across the sidewalk to identify the moment at which pedestrians are lined up with the Confederates. On the Upper East Side, it was the edge of a planter. In Midtown, here's the Midtown camera, it was a low border wall, a low wall bordering an adjacent plaza. Our primary dependent variable, as pre-registered, is the difference between the distance to the confederates and the distance to the baseline object. So that is, we correct for some of the distortions created by the camera by focusing on the pedestrian's position in relation to two different fixed points, which represent the extent of the available sidewalk when the pedestrian is passing the confederates. Okay. So how do we move from video to data? We used an open source image processing program called ImageJ to manually track the pedestrians in our image data. RAs were assigned segments or frames of recorded video and instructed to record three things. So first, they captured the X and Y pixel coordinates for each pedestrian entering the area of interest by clicking on the pedestrian's head. They then did the same thing for the confederates and for the side of the baseline object closest to the confederates. The RAs also watched the whole video from which their segments came and determined whether the same pedestrian appears in multiple segments. So each unique pedestrian gets a unique ID number, shown as the track number here. We check for intercoder reliability in a few ways, which I could go into in the Q&A if people are interested. For a subset of the data, so basically what we did for intercoder reliability was for a subset of the data, we had multiple research assistants code the same video. We also hired a postgraduate research assistant to check all the tracking for any obvious errors. And then we present a number of measures of intercoder reliability, which I can talk about in the paper appendix. So you might be asking, why not automate the tracking? The biggest obstacle here is camera resolution. So we could automate the tracking, pedestrian detection and tracking, as I'm sure everyone in the audience knows, it's fairly straightforward using existing technologies, right? However, what we're interested here is not simply tracking the pedestrians, but capturing the distance between people. And this presents challenges in low resolution images because the automatic detection gives us a box, right, that contains the pedestrian and introduces additional noise. We did try this and decided to opt for human coders. However, as I alluded to before in another project, which I'll speak to at the very end of the talk, we have video of much higher resolution and are automating in that context. So the actual data, the raw data, looks something like this. Within each site, we have pedestrians who are observed in multiple images as they move across the scene. From the X and Y pixel coordinates explained on the previous slide, we can extract the distance measures that I described earlier. Okay, baseline distance, which the variable name here is wall underscore distance, or distance from a given pedestrian to the baseline object, and confederate distance, or distance from that pedestrian to the confederate. Distance diff here is equal to confederate distance minus baseline distance, which gives us how far a pedestrian is from the confederate location relative to the baseline object as explained before. So more positive values reflect more avoidance, right? The pedestrian's closer to the baseline object than to the confederate location, and negative values reflect less avoidance. So the pedestrian is further from the baseline object than to the confederate location, and 0 reflects equidistant. So we subject our test to a range of different measures, some of which don't rely on the baseline object at all. And I'm happy to talk about those if people are interested later on. Unsurprisingly, given that our study is a randomized experiment, the particular measurement choice doesn't affect our outcomes because the primary variation that we're exploring is researcher controlled, right? That's the part that we randomized. As a further robustness check, we also develop a simulation in which we literally model our scene using 3D animation software. So we use Blender. And the idea here is that we essentially recreate our camera view, rerun our experiment, and then rotate the view so that we can observe the scene from the bird's eye view, right? Because bird's eye view is what we actually want. And because it doesn't have those perspective problems that I described moments ago. This allows us to show that the distortions that result from the camera angle don't invalidate our findings. So back to the data, the rightmost column in the data is an indicator for whether pedestrians appear, whether the pedestrian appears within a particular area on the image, which is the area we deem most relevant. So let me show you what I mean by that. So in our main analysis, we only include pedestrians that appear in the part of the image indicated by these yellow bounding boxes. We use naturally occurring physical barriers, so a canopy and a wall that marks the entrance to a plaza, to determine relevant spaces. So for example, if someone crossed the street to avoid passing our confederates, they would not be included in the main analyses. We think that if anything, this would mean that our estimates of pedestrian avoidance are on the more conservative side, right? Because we're not capturing people who go far out of their way to avoid the Black men. One not pre-registered idea that we haven't yet implemented is to test for differences in the total pedestrian flow or volume in the three conditions, which might give us a handle on whether people are going out of their way to avoid our confederates to the extent that they don't make it into our bounding boxes. Okay, so as pre-registered in the paper, we only use the measurement for each pedestrian that's closest to the confederate location in our main model specifications. We think that this approach helps to minimize the error due to visual distortions. We show in the paper that our findings are not sensitive to this measurement decision. So for example, models that utilize all the observations for each pedestrian yield the same substantive conclusions. Okay, so we have our experiment. We have our 3D to 2D measurement conversion. Let's come back to the hypotheses that I laid out at the start. To test the first hypothesis, right, that pedestrians will give phenotypically Black confederates a wider berth than phenotypically white confederates, we can simply take the difference in means between avoidance in the Black confederate condition and in the white confederate condition. To test the second hypothesis, we're going to compare the behavior of Black and non-Black pedestrians to the best of our ability. This is a little more challenging and some caveats apply. So first, we need to measure pedestrian race from afar without being able to ask people to self-identify. We attempt this in a couple of ways, using a mixture of on-the-ground coding in both locations and video coding on the Upper East Side, which is that more residential location. To do this, we ask our research assistants to give their best guess of pedestrian characteristics, including race or ethnicity and gender. So I'm happy to talk more about this in the Q&A, but basically, we originally wanted to be able to compare Black pedestrians and white pedestrians, but it turned out to be feasible only to look at Black versus non-Black pedestrians, according to the guess of the research assistants. Basically, on the ground, on the days of the experiment, the research assistants found it too difficult to do anything other than flag pedestrians whom they thought to be Black. And then in the videos, only the Upper East Side view proved clear enough for this type of coding. So thus the set of controls that are used in the analysis are slightly different in the two locations. It's a bit of an aside. Okay, so second, we simply don't have many Black pedestrians in the data, right? So the analyses of that subgroup are very noisy, as are the statistical comparisons between the subgroups. For both hypotheses, I'm going to show you the results from simple ordinary least squares regressions, both unconditional, so no covariates, and controlling for pedestrian characteristics, race and gender where we have it, and block fixed effects. So blocks are those 45-minute time chunks that I mentioned. Standard errors are cluster bootstrap to account for dependence in the 15-minute clusters, which is the unit of randomization. Okay, so for hypothesis 1, I'm going to show you two sets of results, unconditional in the upper panel and conditional in the lower panel. To orient you, the horizontal axis here gives the treatment effect in terms of the standardized pedestrian deviation. Basically here we're standardizing by sidewalk width to make the results from the two sites more comparable, as pedestrian behavior is in part dependent on the amount of room that one has to maneuver. The dotted line, of course, is zero effect. So to the right of the line represents greater avoidance in the presence of phenotypically Black confederates compared to white. For all pedestrians across both settings, the unconditional average treatment effect shows evidence of racial avoidance. These black lines represent 90 and 95% confidence intervals showing statistical significance at conventional levels. So to interpret this somewhat obtuse effect estimate, we use information about the total width of the sidewalk to back out a more meaningful number. So pedestrians give Black Confederates roughly 10 centimeters or 4 inches more space than white Confederates. For completeness, let me show you the results broken down by site, conditional on covariates and block dummies, and the results are all consistent with hypothesis 1. So as you'll note, there's a bit of a difference in the results between the Upper East Side, right, that's in orange, and Midtown, which is in blue. On the Upper East Side, we have effect sizes that are larger in magnitude, about 15 centimeters with controls, but we also have more uncertainty. We think that the large confidence intervals have to do with a smaller sample size. There were many fewer people walking around in that scene. Remember, the Upper East Side is this more residential location compared to the Midtown location, which is this, bustling commercial area. But we also thought, a priori, it's actually in our pre-analysis plan, that people walking on the Upper East Side were more likely to exhibit racial avoidance. As I noted that this neighborhood tends to be whiter, a little bit wealthier, and more conservative. But it's also just a much less hectic environment, right? And also a residential one. So it's possible that people walking there are just more attuned to who is on the sidewalk. So let's now consider hypothesis 2. I'm going to show you results from the same specifications as before, right, with the same horizontal axis, though note that the range of the axis is much larger because one of the results is very noisy. So previously it went to 0.15 and now it goes to 0.4. So this is a much it's a larger, the axis is different. So the left panel shows results for pedestrians who were coded. So the left panel is going to show results for pedestrians who were coded by our research assistant observers as Black, and the right panel for those who were coded as non-Black. As you can see, we find little evidence that Black pedestrians avoid phenotypically Black Confederates. While the point estimates are noisy because the sample sizes are really small, they're close to 0 in magnitude and even sometimes negative, though we're hesitant to infer much from that because only about 6% of pedestrians were coded as Black. For the non-Black pedestrians, the results are generally much stronger, right? About 10 centimeters in Manhattan and 17 centimeters on the Upper East Side with controls, and more precise than the results I showed you on the previous slide, suggesting that the support for hypothesis 1 is largely driven by non-Black pedestrians. Okay, so I began this talk with a story about Senator Raphael Warnock, whose campaign ads were specifically designed to put white Americans at ease. His experience on the campaign trail accords with the stories we've heard from numerous Black people and other racial minorities across many countries about their experiences on sidewalks, in elevators, at shopping malls, and everywhere in between. Right? Everyday racism is real, even when white people don't necessarily notice it. In this study, we provide systematic social science evidence of one type of everyday racism, pedestrian racial avoidance. One alternative interpretation of our findings is that pedestrians are giving Black people space rather than avoiding them. So we reject this interpretation. If you take a look at the literature on proxemics, which studies how people use space during social interactions, there's evidence of physical avoidance of stigmatized groups in a whole variety of contexts, as well as work that links patterns of avoidance to implicit measures of prejudice. We combine big data with a field experiment, right? Our big data here, video feeds of sidewalks, provides a unique opportunity to solve a sticky measurement problem. But measurement is only one piece, right? The field experiment provides a causal interpretation that rules out alternative explanations of the phenomenon we observe. Our approach provides a replicable way to study mass pedestrian behavior. It can be used wherever cameras capture pedestrians and can be used to study different contexts and behavior in relation to Confederates with different characteristics. Especially now that public cameras are increasingly ubiquitous, these tools can be used to study many different types of questions. So for example, along with my co-author Bryce Dietrich and some other collaborators, including Shobik Harari, Barari who's a graduate student at Harvard, Jake Brown, who's also a graduate student at Harvard, and Ryan Enos, who is a professor at Harvard. We've been collecting data from over 200 public cameras across the United States since the beginning of the pandemic in March 2020. So this is work that's currently supported by a grant from Cisco Systems and the Silicon Valley Foundation. And the motivating idea here is that we can use public cameras to study social distancing and other pro-public health behaviors in an unobtrusive way. So most studies of these behaviors that we've seen come out in the past year rely on self-reports, which can obviously be problematic. So some researchers are using cell phone location data, and we have access to that data and plan to bring it into our study. But the cellular data has other limitations. So for example, it's not precise enough to tell us how close any one individual is to another, or if they're wearing a mask, like the person in the bounding box, in the green box, in this image. So as you might guess, right, there are cameras everywhere. Some are part of major city camera networks, like in New York and Seattle, while others show, various American towns and cities. Others are in more remote locations. This is one of my favorites in Nome, Alaska, which is apparently snowy year-round. Some capture nature trails, others boardwalks, or other kind of tourist attractions. Okay, so the processing is in very early stages, but I'm going to kind of give you a rundown of what we've done so far and where we're going. So first, really, when I say we, I mean an army of undergraduate research assistants, combed through hundreds and hundreds of cameras and identified the ones most usable for our purposes, those of high image quality that also capture people. A lot of them are high image quality, but they capture, a city skyline and you don't see any people in the images, okay? Then we started scraping. So when I last checked, a couple months ago, so these numbers are now out of date, our data amounted to about 2.1 million hours of footage, or 93 terabytes, and at least one angry email from a city IT officer so far. So next, we ran object detection classifiers to automatically detect people and assign a detection certainty score. For this, we just used canned object detection models in TensorFlow, right, which are really good at detecting people and images. This allows us to filter out cameras and images that we're fairly sure do not contain humans. Right, there's lots of camera images where there are no people there, and it's not always useful to us to have that. Also, because data storage is its own kind of daunting task in itself, we kind of made the decision to only store images that have people. So next we okay, sorry. So let me say something about what we're doing here. Okay, so from there, we created a set of randomly sampled images for our human coders to evaluate. Right, the green box in the previous images that I showed you indicated an object that has been detected to be a human. Through multiple iterations of testing, we developed a survey for our human coders to record a set of attributes about the people in each image. So these include things like, does the person appear to be alone or in a group? How much distance do they appear to be maintaining from other people? If they're in a group, how much distance is that group maintaining from other people in the image? Do they look like they're going to work or shopping or exercising or going to school? Do they appear to be wearing a mask? We also ask for the coder's best guess of people's characteristics, such as race or ethnicity, gender, and approximate age. That's possible it's plausible in some images, but not in others. Okay, so we've got a bunch of research assistants coding randomly sampled images. Right, this is our training data, which we're using to train a neural network to classify the public health behaviors and underlying attributes of the people found in the 2.1 million hours worth of data that I mentioned before. Right, and our scraping here is ongoing. So in the end, right, we're going to have a massive data set of geolocated, time-stamped public health behaviors and pedestrian covariates. There are many obvious applications for this type of data. So for example, descriptively, we will be able to say a lot about how Americans did or did not change their behavior in response to the pandemic. But beyond this, we hope to be able to estimate the effect of various public policies and public messaging strategies on real-world public health behavior. This is because states and cities in the US, which is this highly federalized, highly fragmented city, enacted various health measures. It's a very the US is very fragmented and federalized, right? And so states and cities enacted different health measures at different times, and for different, often political reasons. So in addition to connecting this data with policy variables, we can also connect it with political data like partisanship and with health data like COVID-19 case rates. The rich geographic and temporal variation in our data should provide numerous opportunities for credible observational causal inference. So I'm going to close here by noting that this is an approach that I think is extremely promising for social scientists moving forward. So big data is changing our ability to measure the world, but measurement is only one part of the social scientists' toolkit. There's much to be learned by combining these new technologies and novel data sources with experiments and quasi-experimental methodologies for inference. And so with that, I'm going to close, and I'm happy to take questions and comments.
Okay, thank you. We have two questions in the chat right now. First, Olga Gasparian asks, how did you get the camera data? Is it public domain?
Yes. So if you Google webcam, like webcams, and pick your city in the world, right? There's a ton of these video feeds. The New York City data in particular, if you go to the New York City Department of Transportation website, all of the cameras are, you could watch what's going on in, pick your intersection in New York City right now. We did tell the New York State Department of Transportation what we were doing, and we kind of signed a data sharing agreement. But that's not, we did that more for, just so we could, dot all our T's and cross all our dot all our I's and cross all our T's. Yeah, so it's all public.
Great. And the next question here from Stefan Webb is, and I'll just read it out. Did you take into account the behavior of the confederates? If I walk down the street and someone looks or stares at me directly, for example, I would swerve no matter what race the person is. Similarly, did you track whether the pedestrians were looking forward or at their phone screens?
Yeah, so the reason why we decided to have, one of the reasons we decided to have two confederates was so that we could give them very clear instructions to look at each other and talk to each other the whole time, and it would appear natural. So we know that they weren't looking at their phones. They weren't looking at the pedestrians or moving around. They were in a fixed spot having a conversation all day long. But I agree that that's an important, it's an important question, right? Because the behavior of the confederates could certainly affect how pedestrians respond to them.
Right, and Julia Gibbon asks, can you tell us more about how you encode the video feeds data and people's coordinate positions?
So we capture the images from the cameras, and then we use the ImageJ. We train our research assistants to use this ImageJ software, which automatically records the coordinates on the image when they click.
Okay. And Ruth Dittelman says, great project. I have one question. Did you check for the time of day? I imagine that if the mechanism is threat, the effects should be stronger as it gets darker.
Yeah. So that's definitely an important consideration. So we took care to do the experiment during the time of day when it was not yet getting dark, and it was summer when we ran this, so we had a lot of daylight to choose from. We didn't check for differences by, well, okay, we did in a way. So because we did this block randomization that I described, right, we split the day up into these 45-minute chunks, and then we randomized the 3 conditions within each chunk of time. So that's going to hold constant. That's going to mean that when we include those block fixed effects, we're comparing chunks of time that are really close together, like within the same 45-minute period. We don't see, we do see variation across the chunks of time. I don't know if we've looked, particularly at time of day. We could do that. But the darkness issue is not. We don't think that's a concern because of how we selected the timing. But thank you for the comment and suggestion.
Right. I'm going to dip in and suggest correlated random effects might be a kind of nice way to get an explanation for your fixed effects in some sense. So Olga asks, or actually says, just a thought, not really a question about New York City location differences. I wonder to what extent the difference in the results between the Upper East Side and Midtown is driven by the tourists' presence. For example, Upper East Side is close to Central Park and the Met, and there are more tourists, and Midtown's lots of people who work there and might be more like working there New Yorkers.
Right, yeah, so I'll say that neither of these places were particularly touristy. The part of the Upper East Side, the particular intersection on the Upper East Side was not close to the Met. It is close to Central Park, but it's it really is like a more, we've spent a lot of time just watching these videos, and I was there when these studies ran, and we had scoped out neighborhoods ahead of time, and we did not get the sense that there were a lot of tourists in the area. I actually think if there were more tourists, they probably would have been in Midtown, sort of passing through. We don't have like a great way of identifying who is a tourist and who isn't, although, if you spent time in New York, you can sort of, it's actually not that, it's not hard to identify the tourists. So just sort of my qualitative sense is that there were not a ton of tourists, but it's an interesting question, how much will the presence of like outsiders in a neighborhood, and by outsiders, I mean people who aren't like walking on that street every day, affect things. On the one hand, we might think that those people some of the tourists maybe are having sort of like a new experience, and maybe they are more attuned to who's around them. Maybe they're not used to seeing Black people on the sidewalk. They came from, Nebraska or some like very white part of the US or some other country, right, where they're not used to that context. And so maybe we expect tourists to be more sensitive to the presence of phenotypically Black Confederates on the sidewalk. But on the other hand, maybe tourists are just so involved in, their maps and the tall gawking at the tall buildings, right, that they don't respond to they don't behave differently in the presence of the Confederates. So it's really hard to know, and it's something that I think like people should go and do more of these experiments and explore these questions in other contexts, because it's certainly interesting to learn more about heterogeneous effects among pedestrians.
Great. Ruth Dittelman also had a comment. She says, I find your results interesting in the light of the fact that maintaining a larger social distance from a Black participant in the lab is one of the few behaviors that correlates with implicit bias scores, which is often being considered to lack external validity. I'd say your results definitely confirm that this behavior has external validity.
Great, thank you. Yes, I agree with you, and I think we should be doing more kind of field studies where we look at this behavior in the real world, because it's not always the same as a lab, and it's good to be able to confirm that it's not. And it's important to know when behaviors we observe in a lab are specific to laboratory settings, right? So thank you for that comment.
Right. Jean-Philippe Cointe says, thank you for the great talk. I'm wondering whether you have considered using less controlled data, but possibly longer video footages with random people walking along the sidewalk instead of using the confederates.
Right. So like the observational analog to what to our study. Yeah, when we first started planning the study, we did think about just trying to observe people. I think we worried about selection, right? As we saw, there really weren't very many people who the research assistants identified as Black in our images, right? And so if we're interested in how people behave, how people of all races behave around phenotypically Black people in sort of like what we think of as traditionally white spaces, like on the Upper East Side, or in wealthy, more conservative, street corners and in cities across the world, right? We kind of need to control the presence of those people on the sidewalk, and we also want to control their behavior, right? Like we want to be able to do that. So I agree that there is this, as a trade-off, right? We could observe a lot more footage if we didn't sort of like impose an experiment on it. But it does come with this, we do lose some control. I'll say, in the past, since the pandemic started, right, it's been much harder to do these types of field experiments where you actually go out into the world and manipulate the presence of people. So along with some co-authors, we talked at great length about doing a field experiment to study actually the avoidance of phenotypically Asian individuals in the US on US street corners during, so this was like much earlier in the pandemic when we talked about it. So to basically replicate what Bryce and I did in New York, but with phenotypically Asian individuals. But we felt there was not a way that we could do that ethically, right? Like, because we would be putting people, putting people on the street. And so we decided not to. And so I do think that, things will the world will sort of like go back to normal in a sense, but there will still be, for a while now, it will be hard to do field studies. And so, doing what you suggested, sort of more intensive observational studies, may be kind of our best bet. And we may learn quite a lot from those. So it's a bit of a long-winded answer to the question, but it's something that we've thought about quite a bit.
Great. I don't think we have any more questions from the audience, so but I will abuse my position and ask one myself. So I'm after being involved in some police bias work in the last year or so, I'm very happy to see this usage of parsings rather than like race of person as the unit of analysis. That actually gets around some nice problems. Gets nicely around some problems. But I want to first ask you to say just a little bit more about selection into the box, as we might say. So who are these avoiders? Is there any way to get at people who have crossed the road to avoid the whole thing?
Yeah, so I think it's a great question. So I will say, like, qualitatively, we don't see a lot of that happening. And it may be, when we picked the places for the Confederates to stand, we were kind of maximizing over a number of dimensions. But one of the things we were thinking about was we wanted them to be in a spot where it would be a little bit harder for people to, we want to kind of balance balance off like we didn't want to be fully blocking the sidewalk, right? We also didn't want it to be kind of the case where they were so obvious that people might just like cross the street because the sidewalk is blocked, if that makes sense. So I think like particularly in the Upper East Side location, actually in both locations, if you're walking, you wouldn't have necessarily seen those people standing there until you got closer to them. There were a lot of obstructions kind of prior to them on the sidewalk, like like a hot dog stand or trees, right? So you might not have seen exactly who was there. So I think that made that type of avoidance more difficult. But yeah, I think it would be really interesting to be able to measure this. I think if we ran this again and did it over a longer period of time, we might be able to detect these people who are like, severe avoiders, or what you might call them. So the approach that we've sort of thought about but haven't implemented yet is just basically looking at like the volume of people across the different conditions that appear in our bounding box, which, like, because it's a randomized experiment, we should have really good balance across conditions in the volume of people that make it to the box. And if we don't, that suggests that people are diverting before they enter the box. I think that like this, there are these cameras that I love that are in these like little towns in rural Montana and North Dakota, like places where there are very, very few African American, very few people who aren't white, right? And so I would expect to see much more of this like kind of diversion in those settings, and it's something that I'd love to study once we can kind of get back in the field again.
I think we have time for, we have a time for one more question, I think. Olga asks, I wonder what the effect of the gender of the pedestrians and whether you checked it. Are women avoiding more? Yes
and yes. Women are avoiding more, for sure. In fact, I haven't looked at this in a while, but women are kind of driving the effect. So absolutely, yeah. And one of the things we would love to do in the future is to randomize the gender of the confederate, right, and see how that affects things. But yes, your instinct is spot on.
Great. Okay. Actually, one last, perhaps there's space for one more, about the bird's eye view. So you were saying that ultimately what you'd like to see is from above, but it seems like in this, I don't quite know how to put this tightly, but maybe that isn't the view that you want, because you can't actually implement it as a person avoiding someone. So what you're actually doing is, in some sense, veering around conditional on whether they're looking at you or whether they have their back to you, or some geometrical function which is not actually just distance. I get that distance is a thing, but in some sense, the ecological quantity is like being within arm's reach, or being like in the zone of being talkable to, or something like that. I'm just sort of wondering about alternative thing, like how to think about distance in like not centimeter terms. Whether there's a version of social distance which is not, shall we say, linear in centimeters.
Right. Yeah. So I think this is really interesting. When we were first setting out to do the study, we were hoping to also study like speed or velocity. So do pedestrians, like, do they speed up when they're passing a phenotypically Black Confederate? We weren't able to do that because the refresh rate on these cameras is like annoyingly slow. I think now, we ran this study now quite a few years ago. I was still in graduate school, which kind of gives you a sense of maybe I had just finished graduate school, how, you know, the research process takes a really long time. But now that there are these much better cameras that are like live video, right? What we really have is like a series of stills. It could be, I think it's plausible that speed and velocity could be used as a measure of avoidance. Because I agree with you that distance is like, it's a proxy for what, it's a proxy for something. It's not quite what we actually want to study.
So thank you very much to everybody for participating, and we look forward to seeing you at future seminars.